We are now recording.
Well, welcome. Oh, you look very festive.
It's my Antarctica McMurdo shirt.
Oh, very good.
It says,
Oh, it is a McMurdo.
yeah, McMurdo Station, Antarctica, living the dream, established 1956.
Very good.
Yeah, it's a real deal.
That's a small club to get one of
Yes,
those, right?
that's right.
Well,
But there's multiple people on this call who are part of that club, I think.
yes, I'm sure.
That's true.
Yep. And Jules as well. Didn't you go to McMurdo or someplace else?
Yes, I was at McMurdo and Bird. I missed Pole, but I got to McMurdo and Bird.
Very good.
And also Cape Howlett to the Rookery before you could no longer mix with the Penguins.
Oh, very good. Well, welcome to the March 30th, 2021 session of TangerineSDR and Hamside technical session. My name is Dave, KV0S. And this week, I've continued a little bit on programming. I've gotten sidetracked by some leftover work from my university job. We're writing a book, and I'm one of the editors. And the papers are all due. We're being published by Springer, so papers are all due in April. And so we're in the crunch time to finish up the book. So I've had a little bit of work to do with that got cut into my radio time. So that's about it for me. Next on the list is Nathaniel, W2NAF. Go ahead, Nathaniel.
Thank you very much, Dave. Things are going fine here. I've just been continuing on with, working with students and trying to keep things going. W2F, back to net.
Very good. Next on the list is Bill, AB4EJ. Go ahead, Bill.
Well, thanks, Dave. Good evening to the net. I'm here in Orlando with my daughter and her massive family. Just got finished helping a sixth grader with his calc homework. Do you remember how to integrate by parts? No, I'm pulling your chain. He's not doing calc. He's in sixth grade, but he's doing algebra.
Oh,
so,
wow.
But anyway, I didn't get to that till I was in ninth grade. So, but everything's moved up. I'm just going to give my report and then kind of slip out of here to get back with the family. But anyway, I've just been playing a little bit with creating images this week. I created an image of the Grape version 1 that's also got the automatic restart and GNU radio and output and digital RF that's ready for the Antarctica project, and uploaded that to Box so that Christina should be able to get it and burn some images for that. And also experiment around a little bit with creating a burnable, bootable image for the Tangerine localhost, what I have so far, just as an experiment, because it's, I'm sure we're going to find more to do to it to fix things once we have hardware. But that's my report. Back to net.
Fine business. Hey, when you're helping kids, it's fun. You get this feeling. I used to know how to do this, but I can't remember. It's been a number of years. Anyway, sorry.
Yep.
Next on the list, we have David McGaw, N1HAC. Go ahead, David.
Hello, all. Yeah, I've been traveling myself. Just got back from being down at Wallops for 2 weeks, putting our VLF propagation rocket together successfully, I believe. Launching in May, here's hoping. And on the way back, I was able to stop in at and visit with Yeoman Kim and Bob Melville. We're talking Antarctic ego type stuff. And Yeoman was thinking we might use something akin to a Grape for a project he's working on. down there, down in Antarctica. So we'll see. A lot of places to put these things and a lot of ways to use them. So back to Nat.
Well, it sounds like good cross collaboration. So very good. Next on the list is Bill N8ET. Go ahead, Bill.
Well, not too much to report here. I was going all week. I was up in Ithaca, New York, unloading my mother's apartment. She moved into assisted nursing or advanced nursing or whatever they call it when you're 96 years old and can't hardly move. I was supposed to get my Grape boards in today, according to the post office, but they didn't show up. But I assume they'll be here tomorrow. So that at least was happening while I was gone. And that's all I've got at this point.
Well, very good. Next on the list, we have Dan N4XWE. Go ahead, Dan.
No, thank you, Dave, and hello, everyone. I'm going to go without the photo. I just had some surgery done last week, and I'm still kind of suffering the after effects of a skin graft. So anyway, haven't done a lot. Did manage to catch up on the presentations of the conference and enjoyed that tremendously. Other than that, not much going on. Back to you, Dave.
Well, it does sound like you have had a lot going on, and best wishes in your recovery. Next on the list, we have Dave KD0EAG. Go ahead, Dave.
Hello. I can't turn on my video, but it's no worse than usual. Not done anything remarkable this last week. There have been endless interruptions. Did get some stuff ordered. Just got word from Digikey that something I ordered, I think last Thursday, has just gotten processed. So some stuff to diddle with those Fluxgate magnetometers, but that I have. But otherwise, nothing exciting to anyone, I don't think. That's all.
Well, fine business. And next on the list is Dev KC3PVE. Go ahead, Dev.
Good evening, everyone. So we're starting a new week here in Scranton. I'm continuing my work. There are a few new steps that I'm taking in my research, and I think it's going okay, if not great. Thank you.
Very good. And thank you for sending out the meeting links each week. That's not a real exciting job, but it sure is appreciated.
Yes, I'm good at this kind of jobs. Thank you.
Okay, and next on the list is James KG4DSG. Go ahead, James.
I think it's on now.
Yep.
Not much to report here. Just listening in, and with that, back to the net.
Well, fine business. And then next on the list is Jay WB8SBI. Go ahead, Jay.
Howdy, everybody. Good to be here as always with my fraternal brothers and sisters in amateur radio. Nathaniel, thank you for creating that Google list about the Grape. So I'm on there. I haven't been able to check it this week, but I'm looking forward to getting active in that and finding out what all is involved. So I'm assuming from what it sounds like that even if I get the board, is there things like a bill of materials that exists? And do we have to individually go out and buy those parts, or is it already somebody has a stockpile of them that can put them in a bag? I'm interested in that part, and I'm assuming that I would have to assemble everything, assemble all the parts. So if you could comment on that, where do we go from here? Other than that, nothing really new here from the northern suburbs of Detroit, Michigan, the motor capital of the world. Back to net control.
Fine business. I think John will be able to answer your questions, and he's just a couple down the list. So we'll leave that for a minute. Next on the list is Jim, K4BSE. Go ahead, Jim.
Good evening, all. Well, not a whole lot here. I stuck my foot in my mouth last week, and volunteered to head up the help group on the Grape one. I think we're calling that the Grape Bunch 2, aren't we? And I was asking this afternoon if we had heard a response from people that got the email about it. So if we could maybe start organizing that a little bit. And I just checked my email. I didn't see a reply in there, but there might be one that I missed.
Very good. Well, we'll see if John has any additional parts to that. He's coming up on the list in a little bit. So next on the list is Joe, W7LUX. Go ahead, Joe.
Hey, good evening, everybody. I think I'm probably got the audio working. Zoom and I don't get along very well. I assembled one of those Grape WWV receivers and got it running and been experimenting with that and watching the fluctuations on 5 megahertz WWV. And general information is what I did is I got a bill of materials from John and checked everything over and ordered them from Digikey. If somebody wants one, just send me an email, w7lux@arrl.net. And ordered boards. Boards take a better part of a week to get from Oak something. I forget the name of the place, but I could provide that also. And I've been checking the web page set up for Grape, but nothing has appeared on it except a comment from Nathaniel. And by the way, thanks much for sending the URL. I couldn't dig that up out of the history of the Chrome. But anyway, so that's what I've been up to, experimenting with the WWV board. I've got lots of hints for people that want to put one together, and there's a bunch of very small parts on there. So you better get your really sharp soldering iron tip if you want to put one of these things together. And I'm certainly available for questions, answers, whatever. W7LUX@ARRLnet will get you here. And that's I've just got an awful lot of projects going on, so it may be a little wee bit slow, but I will get answers back to people. And thanks, Dave.
Very good. And maybe Nathaniel, have to get you set up with access to the website to document some of yours and Jim's information. And next on the list is the builder himself, John N8OBJ. Go ahead, John.
John N8OBJ, getting some traction actually on getting the simulations for the Grape 2 front end buffer and the 4 notch filters. They're a lot notchier than I thought they were, so we're going to probably have to do something separate for CHU channel. They're not overlapping enough for enough gain. But in reference to the Grape 1, I did create a bill of materials that is Digikey friendly. You can't, what they say you can do, you really can't do, because I tried to share a bill that's already preloaded, but you only can share it within your own organization. So unless you're at case.edu, you're not going to be able to see it. So I created one that is specifically just for the upload, and I verified that it works. And I think I sent a copy of that to Joe, and I believe he tried it, but he had actually already ordered there's 28 parts on the bill of materials, and it comes to, I don't know, $23 plus shipping. The boards are through Oshpark. You get 3 boards for $6.60 shipped. Their standard turn is usually 5 to 7 business days for the boards plus shipping. It usually works out to about 2 weeks. I think there's going to be some coordinated effort through Jim about possibly maybe putting kits together or ordering sets of boards, and I'm not sure what's going on with that. The other thing I owe Joe is an image of the micro SD to run the Raspberry Pi. I'm going to try and zip it and see if I can get that up on the website, because I tried before and the file was greater than 10 gig and it would not go up. So I'm working on that. I am not going to pursue trying to get the uploads to my own box account going due to time and from what Nathaniel has instructed me to do. Let's see, other than that, I don't think there's much else to report. Chris, I'm supposed to be answering a question for somebody. One thing I do want to mention, this receiver is not for audio use. It's a low IF conversion only. And really the only thing you're supposed to hear out of it is a 1 kilohertz tone that varies about a half a hertz. So you're not going to really hear anything useful. You will hear the upper sideband portions of the 500 and 600 hertz tones, but it's going to sound kind of weird because it's not amplitude decoded. It's only the sideband information directly. So it's a low IF receiver. It's not really a radio. So I want to control everybody's expectations. It's going to sound like crap, and it's supposed to. So back to Ned.
Well, very good. It sounds like we got the beginnings of some good help, user help. So next on the list, we have Jonathan KC3EEY. Go ahead, Jonathan.
Hi, everybody. I don't have too much to report. I'm kind of busy with a non-technical writing project that I'm on the hook for, but I do have I received an email last week from I believe his name is Bob McGuire. I actually just had it in the window here, and as I switched, it went away. But he apparently he's an adjunct at Virginia Tech, and he asked me about the processing methodology of VLFRX tools. So what I did was I gave him a link to Mike Smith's site, which has block diagrams and information on how to actually use VLFRX tools in an application for natural radio capture. I remember hearing his name before. Nathaniel, I believe you also know him as well. But other than that, that's all I have. Back to the net.
Fine business, Jonathan. Bob worked a lot on some of the SDR programs early on, and he was one of the co-authors of DTTSP, which was a digital signal processing library in C, and was used extensively. So
I think I know him. It may be the same person I'm thinking of.
Well, he was on here last week.
Pardon me?
He was on here last week.
Oh, okay. I missed that meeting. Yeah. He is the guy I'm thinking of. He was super active in AMSAT.
Yes.
For a long.
Yes.
Yep. Same guy.
Same guy.
Really, he's really, really technically talented.
Yes.
He's really, really good.
Yes.
And he's a nice guy too.
Yes. So just a little background so that people know who he is. He was here last week. I don't see him this week. And so next on the list, we have Jules, K2KGJ. Go ahead, Jules.
Good evening, Dave. And the list Nathaniel, again, thank you very much for starting that Grape group. Relatively uneventful week. I had my second Moderna shot on Saturday afternoon. By 11 in the evening, I felt like I'd been hit by a truck and was at bed rest for the next 24 hours. After 36 hours, back to normal, but it was interesting. Ordered 3 single-axis FlexGate magnetometers from a source that Hammond and I had looked at, waiting for those to come in, and we'll compare those at some point with the RM3100. Other than that, I'll pass it back to Dave, and thanks. See you soon.
Very good, Jules. I went through the same treatment this week, but maybe not quite as bad as yours. But I was sore for about a day. Anyway, next on the list is John KJ6IBP. John, are you there?
I'm here. Well, I until I learn some new skills, so far, all I see I can do is being an equipment operator, setting it up after I buy the equipment and operating it. I'm planning on buying a Raspberry Pi 4. That seems not bad of an idea. And I'll be able to use it with this project and other projects like the Weather Service whenever I get around to buying suitable hardware for weather. That's it so far.
Well, that's a good place to start. So just thank you for attending, and hopefully you find it interesting.
Oh, so far it is definitely interesting. Even if some of the material is a little mysterious, like when you talk about the parts of that circuit board.
Oh, okay. Well, good luck and hang in there.
Mm-hmm. Thanks.
Okay. Next on the list, we have Michael, AAAK. Go ahead, Michael.
Oh, thank you. Greetings to everyone listening. Back to you, Dave.
Very good. And now we have Scotty, WA2DFI. Go ahead, Scotty.
All right. Thank you, Dave. Well, this week was a replay of a couple of weeks ago. Monday night after the meeting, we went out and got COVID shots again. Worse than last time. It knocked me out for about 3 days. So it was not fun at all. Ended up with 102-degree temperature on Tuesday. And this is not fun. But pretty much over all that, got some work done after the recovery on the clock module and the data engine, and pretty much have the clock module done. A few tweaks we made to it. I'd like to talk to Tom a little bit about those tonight if we've got time. If not, we'll do it offline. And I've been working on what are they called? The connector interfaces, whatever it is. Anyway, the documents that define the connector pinouts and the definitions of the pins, and trying to update some of those. It's been since 2019 on the data engine one document, so it's about time for an update. And we've switched pins all around to make it route better, and lots of modifications. So got to get all that folded back into the documentation, trying to get the clock module and the RF module and the leaf module connectors all defined, so I can distribute them to like Jonathan and Tom and John Ackerman, so everybody can look at it and say, oh yeah, this looks okay. I mean, they will all match, and whether we forgot anything or not, because we do have some spares, so we could define those in a particular way if we wanted to, but just mostly trying to get the documentation in order and keep the CAD guy going. He's had some other projects to work on, so he's been a little bit busy, but I've been able to squeeze in a few mods here and there. And as we review the layouts that he's given us and the routing that he's given us, to see if we can find anything that needs improvement. And so far we've had a few things, And it's getting to the point now on the clock module though that I think we're like trying to stir cement that's hardening fast. So you know, it gets to the point where it's so locked down, like Dave says, it's the domino effect. You make one little move one little resistor, and then you got to move all those, then all that route changes, and all the vias have to move, and then it doesn't route anymore. So you get to the point where you just better have a really good reason for making a change, because it's otherwise you're just going to make it worse instead of making it better. So and in the after time, I can show you the last couple of mods that we made. I think last week we went over the about the 99% done, but there's a few things that we changed to improve things. So that said, back to you, Dave.
Fine business. And so next on the list is Tom N8OBJ. Go ahead, Tom.
Oh, good evening, Dave. And good evening to everyone on the group. Not too much last week. I reviewed a few notes with Scotty on the clock and had too many schedule conflicts last week to be able to get together. This week will be another tough week towards the end. And then the schedule conflict should free up a little bit after that. So back to the group.
Well, fine business. So that makes us open for general discussion.
A quick question for Scotty. It's looking like I may have to play some games on the notch filters to make 3.3, 7.85, and 14.67 work with the resonant filters I have, which means I need to grab 3 more control lines off of the Pi. The ones that are unassigned, are they up for grabs?
Well, as far as I'm concerned, they are. It may mean the difference to us being able to talk to the Grape board if we don't have anything connected to them.
Okay.
That's the only difference. It won't impact you any. It'll just impact us to be able to talk to the board. Now, you know, I'm not sure that this is a useful variant of hardware to take a Grape board and plug it onto a data engine.
Yeah, I don't think it makes sense.
I don't know. So I just wanted to keep our options open.
Right. The other question I have is the middle cost version of the clock module. Is that essentially just the GPS engine and the data synthesizer chip? And, you know, some bypass logic and stuff. Is that essentially it?
Well, they're all that way.
Okay.
I mean, there's a GPS, there's a TCXO, there's a jitter reducer and squarer, there is a and some transformer coupling, and then there's the synthesizer chip, and then you pick your GPS. The cheapest one doesn't have a PPS output, so it's going to be marginally useful, but the intermediate one does. So all you get is a little bit worse performance, and you get only single band operation.
Right. So I'm thinking the middle of one, I'm just tossing this up. Does it make sense maybe just to put the layout straight on my board for the 3 parts rather than using the whole module?
Well, you know, what I'm thinking for you is if you wanted to do that, I wouldn't use the 10 output clock chip. I would use the 4 output clock chip.
Okay.
And so if you wanted to do that, take a look at it. The advantage of this is you can just take the board and there it is. You don't have to do anything. But I'm not really convinced you're going to save a lot of money, because even
it comes down to volume and production, and you know, the connector itself is going to cause me some headaches. So I'm still not there yet. So I'm just tossing out the options, trying to think this through.
The M.2 connector is going to cause you trouble?
Yeah, that's going to cause me some problems. Nothing that's surmountable, but it just...
The synthesizer chip has the same pitch, so you're going to have trouble whether you like it or not, if you use that series of parts.
Yeah.
But they make a 4 output and a 10 output. There's an intermediate one too. Maybe it's an 8 output or a 6 output. I'm not sure which. There's 3 parts in the series.
Okay.
The other thing is that the higher end part has a VDDIO for every output, and the I think maybe there's a 3 IO part that you have, which you could use the lowest. All you need is 1 clock, right?
No, I need 6.
You need 6 separate clocks?
Yeah.
Well, okay, so you're back up to the 10 output guy then.
Yeah.
So
I got the 1 PPS, I've got an 8 kilohertz, and then the 4 local oscillators.
Okay. So what I'm
But I can, yeah, I can play games with some of the other stuff. It's just, I'm just trying to weigh the options of what makes the most sense.
Yeah, I'm just.
So maybe we should talk about this offline at some
Yeah, I
point
think we
later.
should. And I think the other thing is that isn't there a lower limit on the output of these at 100 kilohertz or something? So your 8 kilohertz is below that.
Yeah, I was thinking if I did a synchronous divide by 4 bits or 16, I could run it in at 128 kilohertz and get my 8 kilohertz
Yeah.
clock frequency.
It just depends on how much time you want to spend playing around with it rather than just taking this and using it. Because
Yeah.
I think I would like to use this anyway for this application, whether you use it in the Grape or not. I mean, we would.
My preference would be to use it, but if I'm running into trouble with, 6 outputs that I can't get them all, but I don't know, we'll have to talk. I haven't seen the schematic for it yet, so I'm shooting in the dark here.
So the other thing is, I think John is planning to have this as a tapper product outside the radio. So
Yes.
that would guarantee that you would have a viable stream without having people build them themselves.
Yep. So
John, you're saying notch filters needed for CHU?
I have a resonant LC filter for each channel on the input. And I've been doing some simulations, and the width of the resonant filter is pretty tight. And for getting CHU, the 3.33, I thought 2.5 was going to be close enough, but it looks like it's not going to quite make it. And then there's a 7.85 that I was hoping to either hit the 5 or the 10 with, and that's not going to make it. And the only one that's really close is the 14.8 or 14.7 is close enough to the 15 that I think I can pull it off.
That you probably could. The other two.
But that's why I was talking to Scotty about different bits to control, turning on and off either a cap or a filter select something, or for the input filter that feeds the mixer chip.
Here's something you could do that with the RF module is Tom found a I2C to parallel converter that's incredibly inexpensive. You could just drop that in there and you get outputs to control all the filters.
Sure, and that's certainly a possibility, and I may end up doing that, but I'm just putting feelers out for what my options are. I'm not trying to do anything. I'm just trying to figure out where I sit.
The other idea, John, is you put a double resonant filter in, so that it's like two parallel resonant filters, one on top of each other, so you actually have 2 peaks in it.
Oh, I see what you're saying. Okay, because the other one would short out off frequency. Yeah, that's an idea.
Yeah.
That might.
John, you suppose the boards can be built for either CHU or WWV, or do you have to have both on the same board?
They both have to be on the same board because you want to be able to. I think Nathaniel wants to be able to select any of them anywhere. And then when we go over to Europe, they've got a 9.8 megahertz standard that I have to be able to handle. So I have to look at that. So I have to get that list probably from Jim about what I'm looking at for other frequencies too. So this is where I really got to sharpen my pencil and make sure I get everything covered. So
I have a question for John.
Yeah.
John, may I put the bill of materials on the website that Nathaniel has set up for us, and put comments on there and ideas on what I experienced as I built one of these boards? Is that okay with you?
It's okay. Let me send you the newer version, because instead of using minus signs to glob the component or the identifiers for the parts, I'm going to use plus signs, because a minus can be misconstrued as, so I say C1 minus C3, they might think it's C1, C2, C3. So I'm going to change them to pluses that up, so that when it populates the bill of materials at Digikey, it'll be plus sign, so it's which parts of. But I'll get that to you tonight. But yes, you have my permission to do that.
Okay, well, with Digikey, it works out real well if you just send them quantity and their part number, and there's no problems with that setup.
And that's the last one I sent you was basically that. It was a quantity, identifier, and part number.
Okay, well, it's essential to have an identifier.
How to pull them in and how you had to select them and all that kind of stuff. So
yeah, well, it's pretty helpful to have all the identifiers on a piece of paper when you're putting this thing together.
Yeah,
It's not really needed with Digikey unless you just want to verify the parts or look reasonable.
Well, I figure for people building it, more information to give them is better, and this was pretty low hanging fruit to be able to do it, which is why I did it. But we could make two versions, one with and one without. It's no big deal. You just delete the column. So.
Okay. And by the way, all your clocks are backwards on the screen here.
Oh.
Yeah, your video is backwards.
Zoom does it.
I had inverted it for the ham side thing, and I was told my T-shirt was backwards. And video settings, here we go.
You can't read backwards clocks?
John's made of tachyons. He's going backwards in time.
Antimatter. There, could you read them now?
No, it didn't change anything from this
It
end.
didn't change it.
No, it only changed what you're seeing.
Oh well.
It's been like that for some time.
Yeah.
This reminds me of at the house I lived in at college. Some genius took the analog clock apart and reversed the mechanism inside and made the clock backwards. And until you got used to it, you look at the clock and you go, what the?
Actually, you can buy them that way. Yeah, I've seen that.
Yeah.
Yeah.
So make them for barber shops.
I probably need a new video camera because this is an older one.
I thought you were doing it as a feature.
No.
Well, can't you just change the code in your clock to reverse the segments?
I can. Very easy to do.
John, I had another comment that about something you said earlier, that this is not a general purpose receiver. If you were to broaden the filter, the audio filter out just a bit, to 3 or 4K, it could be used as a direct conversion receiver.
Well, it's not decoding amplitude modulation. You're just getting those direct information from the sidebands.
No, but if you, it's exactly the same configuration as a direct conversion receiver.
Okay.
So if you just made it so that we could hear the full, communications audio band, you set the local oscillator to the carrier, and then you're actually getting properly decoded sidebands.
Yeah, but the sidebands are not amplitude modular or decoded. I'm not just detecting peaks. You're just getting the raw frequency. So that, in theory,
no, that is what a direct conversion receiver is.
Yeah.
Oh, you're right. It is the same thing.
Okay.
You're mixing.
I showed you
baseband,
the other week. I showed you a board that I have that Ramsey made. That's a 40-meter direct conversion receiver. It's exactly the same configuration that the Grape is. It's just intended to go dead on the carrier, not 100 kilohertz off.
Which you can
Looks
do
like
with
a soft rock.
What's that?
Looks like a soft rock.
Yeah, pretty much.
The original one.
It's as simple as it gets.
Yep.
But right now the analog bandwidth is 160 hertz to 2 kilohertz, and moving it up a kilohertz or 2 would not be hard to do. In fact, I think Daniel wants that.
Yeah. So
That's
if you
another
did that,
thing you have to figure out.
you just put it, zero beat the carrier, and you've got a direct conversion receiver.
It'd probably sound pretty good on sideband the way it is now. A little bassy, maybe.
Yeah, the only problem is
bad.
that you're getting both sidebands. So if you've got another signal to the side, it will properly decode a sideband signal, but you also get interference from people who are on the other side of the carrier.
Yep.
Yeah, that's true. That's true of that kind of receiver.
Yeah, it's
But
real
it will work.
Yeah, it's real simple.
Yeah. So John Ragland asked, will it be able to receive WWV? And I presume he means so that you can listen to it. That's how you would do it. You would just set it directly
You set
on
your local
frequency.
oscillator. Now the problem is if your local oscillator is off a little bit, you're going to hear that beat frequency.
It'll beat a little bit, but yes.
Unless it's one of the Leo Bodnars, or you have a GPS deal, in which case it's just a DC offset, which you'll never hear. So
right.
But with my 160 hertz bandpass, you shouldn't hear that anyway. So
exactly. No, it should
I
work.
like your idea about the double stack filter.
Yeah, give that a try.
That's a cute trick. I like that. Thank you.
You're welcome.
When I started my WWV receiver here, I offset one of the oscillators by a Hertz or a couple of Hertz or something, and there was a very audible beat between the local oscillator and WWV.
Okay. Was it really low frequency?
Yeah, it's what 2 Hertz.
Because you might be hearing the phasing going in and out between the two carriers. That might be what, and it affects the amplitude.
Yeah,
that's what I'm saying. That's why it's not AM detection. If it was AM, you would hear the 2 Hertz. But if it's not the way I'm doing it, you're going to see the difference as the phase slips, and you get constructive and destructive interference. That's going to amplitude modulate your signal, which is going to really make it sound weird. So even though you have 160 Hertz bandpass, the amplitude's going to be going up and down because the phase is moving around this way.
Right. Anyway, that's what I heard.
Yeah, that makes sense. Nathaniel, been awful quiet. Are you still alive?
I'm here. I'm just tired.
Yeah, I was gonna say, you know, it looks almost as tired as you were last week. Last week you look like a cat had dragged you in.
Oh my gosh, it was so crazy. No, I'm doing fine. I'm just kind of trying to debug this code that I wrote, you know, a year, 2 years ago.
And you didn't do many comments in it?
Oh, I've got comments. I just don't remember like where I left it. And it says that there's some variable missing that's called MATLAB_search, and I'm trying to figure out where it is. The script I have, it's got 1,500 lines. It's got to be in here somewhere. I don't know. It interfaces, yeah, and it's interfacing, gluing together both Python and MATLAB, and it's like my Python interface to FarLap. So I don't know.
Good luck.
Thank you. I need it.
I have a request. I gather that there's a mailing list that goes out that reminds you about these meetings. Could I get put on it? W7LUX@arrl.net.
Yeah, there's
certainly can do that.
Yeah, there's actually 2 mailing lists. There's a general HamSci mailing list, and there is also the TangerineSDR mailing list. And so you can either be on one or both. It's your preference. The Tangerine one is more engineering focused, specifically on the Tangerine, and the HamSci one is a little more science focused. And sometimes there are cross posts between the lists.
Okay, well, Tangerine sounds fine.
Okay, that would be Scotty's department, or you can sign up yourself. I'll put the link in the chat.
The problem is, Joe, if you sign up with ARRL.net, you won't be able to post because you can't send a message from ARRL.net. And it checks to see where the message comes from to see whether you're allowed to post or not.
Oh gosh, I'm running into that elsewhere.
So no, there's a way around it if you want. You can subscribe with any address you want and turn off the email reception, and then subscribe to ARRL.net address and leave the email on. So then you'll get all the email from ARRL.net. But when you send a message out, it'll see that you're still subscribed with the other address. So if you want to do that and you don't want to tell me what the address is in public, just send me an email and I'll get you set up.
Okay, sounds good. I've got your email address. Q.
Okay.
And so you know too, Joe, the links, if you go to hamsci.org and click get involved, the links for the telecons are all right there.
Okay, thank you.
Is this why your email always works so well, Scotty?
Oh, my email. my provider is like the blacklist king. That
no, mine is.
Yeah, I get work emails that we had.
Microsoft is.
Well, we're an Intel partner for all the FPGA stuff, and guess whose domain name is blocked from my server? Intel.com. No email comes through, so I have to use a Gmail address and then go check that periodically because it won't they can't send me any email. It just goes into a hole and nobody ever sees it. So great.
There are ways to fix that. I've even fixed it with Microsoft Outlook, but
yeah,
I have similar problems
to
here.
work on it.
Is there a way to do a Gmail forward so that you could just have a Gmail address forward to another address? So if I were to say,
yes, there is. I have my Gmail forwarded automatically.
so that might work too, because then it
Yeah.
would be coming from Gmail and not from Intel, so it wouldn't get bombed. Anyway, so Tom, are you still here? Do you have a couple of minutes?
All right, I have to double click the button sometimes. Yes, still here, go ahead.
Okay, let me share the screen here, and if I can do that, Nathaniel.
Yep, should be good.
Okay, so this looks like it's going to be pretty much the final clock module layout. You see what we've done is we've taken, of the 3 SMAs here, we've made this one in the middle a through hole right angle. So it's not really in line with these two, because right underneath it is a USB port on the data engine below it. So you can't have, it's physical interference to have the two, to have an end launch, a board launch one in the middle here.
Yeah, that ought to work fine.
So here's the question though. They in the data sheet for the clock module, for the GPSs, they are very explicit about how to route the antenna connection from, this is the GPS antenna.
Yeah.
And the GPS is over here. So what we did is we made the trace 50 ohms. And theory is that a low impedance like that will prevent pickup of a bunch of garbage off of the clock module, extraneous stuff. But it's kind of at odds with what they suggest, because what they want is they want a guard trace on either side of the antenna with stitches to the ground plane.
Yeah.
And what Dave says is that's pretty much impossible to do. We can't,
Okay.
on this board, we can't do it. So what he did, and I'll show you what he did. We start on the primary side. So this, can you see my cursor right here?
Yes.
Yes.
So pin 2 is the antenna for the top, for the top GPS, which is the Z GPS. And then if you go to the bottom layer, that's this via right here is the same via, and it goes to the GPS mounted on the bottom. So we'll have one or the other of those. So at the worst, you end up with this stub here, which is bad, but there's not really anything we can do about it. But you notice this big keep out area here, and it goes to over here, this area over here. And if you go to the trace layer in between, he's got, that's one layer and that's another layer. So here's the trace connecting the via to the GPSs over here. And this via goes to the bias T logic over here, connector.
Yeah.
And what he's done, he's put this right next to the ground plane layer right here and made this 50 ohms. And
yeah, that's the next best thing. Having a picket fence on either side just reduces the ability to couple noise into the line. You know, and how long is that trace? Half an inch?
Yeah, about. The whole board's only an inch, a little over an inch and a half long. So
is there something on the adjacent trace layer?
Yeah, on this layer there is a perpendicular trace that goes through there.
Is that power?
This is I don't know what that is.
Being thick like that, I suspect that's power.
Yeah, I think you're right.
So that's probably fine.
So we got ground there, then the copper trace, which is this guy right here. Then we have the next layer up is this is the interfering trace, and then in the next layer after that, you've got power planes.
Right.
And then the next layer after that, you've got basically trace layer goes from here to here, but it's like 3 layers down. So
yeah, having a power or ground layer on either side of the trace is the next best thing to have in a ground stitch.
Because this trace here is much closer to the ground layer than to anything else.
Yeah, that looks pretty good, Scotty.
Okay, so I was just a little worried because they're making a big deal out of it. You know, this is important. So
well, it is, but you've done the best that you can there. So.
Yeah.
And it is very short trace, so hopefully it'll be okay.
And then you see what we did up here is we this is the oscillator, and we've got the ovals here are actually holes in the board. And then we've got, that's layer 2, layer 3, layer 4, layer 5, and the top layer. So we've got and there's 6 vias in here connecting all those layers together. So what we get is on the secondary, let's see, right here, this is where it connects to the ground, on the ground layer, just these 2 little places here. And then all the other layers are connected together with the 6 vias that go in the middle here that you can't see because they're filled over. So the idea was to create a slug of copper underneath the oscillator that was electrically ground, but was thermally isolated from all the rest of the copper in the board, so that we don't get any heat conduction up into the oscillator.
Okay, so where's the actual electrical ground pad on that crystal?
Right there. Oh, the ground pin on the crystal?
Yeah.
Is right here, pin 2.
Okay, and so that is it's got a nice low inductance ground connection.
Yes, let's see how he did this. Because okay, so he's on the primary, but actually I have, yeah, he gets his, there must be a via in that pad, because
it looks like there is.
It must be, yeah, because I don't see anything on the primary layer, and that trace right there, that is actually, oh, that is on the primary layer. Okay, so he's got the ground pad of the oscillator. It goes into this big slug of ground that then has 6 vias into all of the other layers. And the next layer down from this top layer, which is this layer 2, it has got 2 ground connections right here.
Yeah, see, those 2 ground connections aren't the best from an RF point of view, but
right.
if that pin 2 has got a direct via to the plane, then it's okay.
It probably does not. It probably goes to this slug here. It is connected to 6 vias right here.
Yeah, the planes are cut away.
The planes have, the only ground connections are here and here. There's none on the other 5 layers.
Yeah. Okay. Well,
but it's like,
hopefully the frequency is low enough it's not going to bite you. I've used geometries like that in wideband mimic amplifiers, and they oscillate like a banshee.
Well, this is only 48 megahertz, but it's still not much of a ground.
Yeah.
So,
well, it's not going to oscillate, but it could bounce. Almost would suggest putting more ground on the up top side and cut away the ground on the bottom side.
So we could put a couple of vias to ground right here, but of course anything you ground then detracts from the thermal isolation.
Well, I think, yeah.
I mean, we could do that. We can put a couple of vias right here into the ground plane.
Well, the thing that's going to control most of the thermal movement of that part is via the pads and the pins.
Yeah.
Even though the copper underneath it is going to be stable, it's going to get most of its heat from the pads.
So Scott, if you go back to the ground layer, that has, you currently have the 2 there,
Right.
probably be better to
Those should be
disconnect
underneath
both
the
of
pad.
those and tie the pin 2 as tight to the right.
So then let the pin 2 be the ground for the whole slug of copper?
Correct.
Okay, so if we eliminate these 2 grounds here and then go back up here and put a couple of vias right here, because you got a trace to the ground pad right here.
Right.
But you don't have any grounding to it except through this pad if you remove those
No,
vias.
but
yeah, okay.
But on the ground layer, instead of having those 2,
So we're
one, but it
substituting-
heads off to the right.
We're substituting
right at
the
the
trace
pin.
here for the 2.
No, I'm saying to connect it to the outside ground plane. That would be the ground into your oscillator pad.
Right. That would be the vias on the outside of pin 2.
So you put 2
Oh, I
vias
see.
here where my cursor is.
Yeah.
To the ground pad, ground plane underneath.
Right.
And then you leave this trace right here.
Yeah.
And then when you go to the ground plane, you eliminate these 2 traces right here.
Right.
And then all
Something
of the
like
ground comes from layer 1 on that trace and then through the vias in the center of the pad.
Right.
Yeah.
Because realistically, these pads don't need to be ground. There's no reason why they need to be grounded. I mean, they could float for all I care, as long as the pin is grounded.
Yeah. I think the key objective.
I would ground them, but
Yeah, first and foremost is to minimize the inductance of pin 2 to the ground plane.
Which multiple vias here would help do that.
Yeah, that's exactly right. That will make sure that any clipping, anything that's got a high frequency edge in that part tends not to ring.
And let me look at here and see. So we do have a trace right here that's going to cause trouble.
Well, I would have routed that up above the on the edge there.
Routed it up
Or
above here.
is it
The problem
connected
is-
to other stuff, or is
Yeah,
it
that's
just?
the problem is I can't see. I think there's a couple of 3 vias right here, which is why
Oh.
he ran it down that way.
Yeah, okay.
I
So
still
that
have a problem with the footprint and the thermal isolation because you have all the pads are between the slots. The slots should be surrounding the pads on the outside to prevent heat from coming in.
Well, they are.
But aren't the pads numbered 1 through 6?
You're talking about these pads here?
Yeah, are those pads for the actual part?
Yes.
So the thermal cutout should be around the outside of those guys because that's
Around
what the heat's
here,
gonna
yeah.
pass
And
through.
there's just no way you can do that because there's not enough room.
Well,
And I mean, a trace like this contributes almost no thermal.
Yeah, that should be a little thermal.
So you've got this trace here, this trace here, and this trace here, or your thermal leakage.
Well, the FR4 conducts a lot more than you think it does.
But the copper really conducts.
Yeah.
So I mean, this is a compromise solution because you can't really eliminate all of it. It's just we're trying to see how good we can do.
I could spend about an hour telling you how I did some of the thermal isolation on a reference, but you don't have the room to do it here.
And that's a lot of the things are compromised here because we just don't have the room to do it.
Yeah.
So one of the alternatives to this antenna connector was to put a UFL connector over here by the GPS and just eliminate this connector and then use a pigtail to the chassis. The problem with that is and I thought Dave, our CAD guy, would go for that. The problem is that the bias T components have to be next to the connector. So all of those over here have to move over to here.
Oh, geez.
Plus the UFL connector. And he says he can't do it. There is no way. And he says, then you get into this central clock distribution. He says, as soon as you start screwing with that, now you just ruined the very thing that you've been trying to preserve.
Yep.
So this channel right through here and over to the clock, this is kind of fixed. And if you can see, it's all very symmetrical here to here to here to here to the transformer and then to the clock.
Yeah,
so it flows really nicely all on one layer, no vias.
Yeah, I think your choice of an SMA for the antenna connector is the right one. If you get any of those micro miniature connectors hooked to the outside world, I think you're going to have reliability problems.
Yeah. Well, we were talking about an SMA pigtail to a UFL, but still you can't do it because you can't. There's no room. You see the UFL. There's another UFL connector up here. I don't know if you can see it.
Yeah, but it's not used very frequently.
It's used for external oscillator if you want to turn this guy off, or if you decide that this isn't thermally isolated enough for you, then you basically and what we did is we put the jumper on the enable for this oscillator and just allow you to feed an external oscillator in place of it. Now, I know you don't like this, Tom, but this seemed to be the best compromise we could come up with that would allow you to do this. It's only 48 megahertz.
Yeah.
So, and these stubs they look like giant stubs, but they're like 2 millimeters. I mean, they're like no length.
Yeah, I don't have any heartburn with that because I don't think it's the high runner app. The key is the antenna connection. It's got to be mechanically robust, or I think there might be trouble if it's not.
But what's really nice about this is you can put the jumper on and feed an external oscillator right in here, and without it touching a soldering iron. So this gives you what David was asking about last time.
Yeah.
And by the way, I looked for a connector up here, a UFL with a switch in it. And I defy you to find one because I can find connectors that are similar, but what they're meant for is they're meant for testing of traces and integrity on the board. So like build your cell phone, and then in the production line, you plug your probe in and you measure the traces to see if the impedances are right. Well, the probe itself costs about $150. So no ham is going to buy that to plug an external oscillator in. I want a pigtail that I can buy for $3 that I can plug
Yeah.
on, and they're
Well,
just
Well,
just
Scotty, what I have seen is on Motorola, the old Motorola phones. They had an external antenna connector that had a switch in it.
Yeah, and
And
I
you know,
believe
the connector was cheap and both ends of it were cheap.
I believe you, but I can't find anything.
But I don't know what the source would be.
At any rate, I think this is the second best. If you look at the primary routing, this is the oscillator output on pin 4. We run through pin 3 to the transformer input. This is the transformer primary. It goes to the transformer secondary here on 1 and 3 to the coupling capacitors, to the jitter reducer IC, out of the jitter reducer to more coupling capacitors, and these two vias go to the capacitor network, resistor capacitor network to ground, and they flow into the synthesizer chip right here. So
Yeah, that looks pretty clean.
Yeah.
Yeah.
So does the TCXO have an enable?
Yes. And
Okay,
that's what
so
we're-
you can
that's what
just
we're
flip
running
the
with.
enable on it and then plug in your external
And if you
oscillator.
look at the enable, this is the jumper for it right here.
Yeah.
So it's pulled up internally. So you leave the jumper off, you get the oscillator, you put
Right.
the jumper on, you plug in here, and you don't have to solder anything.
That'll be fine.
One thing you need to be careful of, Scotty, is on the right angle SMA, the pins stick through the board like 100 thousandths.
Yeah, well, we have plenty of room there. We could use
Okay.
an in-launch connector. It's just that you wouldn't be able to plug the connectors in.
Right.
That's the problem. It's the hand access that's
right.
And in fact, it still may be problematic that you may have to unplug the USB connector to screw on the GPS antenna.
Okay.
And if you do, well, my apologies in advance, but 9 pounds in an 8-pound bag, you have to deal with what you get.
Yeah. They're thick pins, but they're soft, so you can chop them off if you have
We've
to.
actually on the TX2 and the HF2, we use surface mount ones of these, and they tore off the board. So
Yeah.
I threw them out and put through hole ones back, and you like Dave says, you can cut them off. They're really soft.
It was pointed out that you've got a left-handed SMA there.
Pardon me?
Yeah, it is.
It's a left-handed thread.
Yeah.
Well, okay. At least it's not a reverse SMA left-handed thread.
Right.
It's artistic license, okay?
That's right. It's the metrics version.
Yeah. Anyway, so that's pretty much it, and Dave's pretty much done with it. He has very little hair left.
I know that.
You're gonna have to work harder on that.
He's either done with it or thrown up his hands with it.
Well, I told him all the easy jobs are taken. All we have left are hard ones. So, and this fit the bill all right. And you can see down in here, to get this SMA in here, you really had to crunch these parts together. These parts here were out here before, and these are spread out. And I even asked them if is this going to be a problem for assembly? Of course, the SMA is through hole, so it'll be put on last.
Right.
But you got to make sure that you'll get these two so close that you can't place them. And he says, "Oh no." He says he always follows standard procedure. So now what I'm going to tell him is that means that most of the time what you give me is way spread apart then from what it could be, because this looks congested, and that's the way I like it. I want it close together.
Well, there's also the issue of the IR shadowing for reflow.
Yeah.
So
Yeah, of course, that connector will be hand assembled after reflow.
yeah, but the clock module is not. That's a little scary. That close to those.
You talking about here?
No, the bigger clock module.
The GPS, you mean?
Yeah.
Yeah.
Because that's a BGA.
This is over 4 millimeters high.
Yeah.
Yeah, no, I don't think it's a BGA. It's actually the leads are on the outside.
Yeah, it is a QFN type part, but it does have pads on the bottom that have to be soldered. All these are ground pads.
Yeah.
Which is
so in essence, it is a BGA.
A pain in the butt is what it is, because all your routing resource gets chewed up with vias to connect these to ground.
Yeah, it's essentially a leadless chip package with a thermal pad on the bottom.
Yeah, the problem with, are those filled vias on the ground pad center ones?
These are just square pads and there are vias next to them.
Oh, they're next to them. Okay.
I don't think I can show you because he's filled it all with copper, so I can't see. There you go. There's
Okay.
the keep outs for all the vias that go through.
Okay.
Yeah, but you can see what it does to your routing. It chops it all up. So.
Oh yeah, it makes a mess.
And then of course this is the bottom GPS, and it's a like almost a dip kind of thing. It's still a QFN, but it's a surface mount, but it's just 2 rows. There's no top and bottom rows.
Is that the medium one or the cheap one?
This is the cheap one.
Okay.
So the cheap and the medium one use the same footprint.
Oh, okay.
And the expensive one uses the top footprint.
Got it.
Yeah, Scotty, did you remember to reverse the pin order top to bottom?
Don't be saying stuff like that, Tom.
Yeah, you got to
1
flip
through
the part.
14 there, and 1 through 12 here.
Yep, you got it. Good.
Yeah, we check those things multiple times because they're the things that bite you in the ass.
Yeah, when you install parts on the bottom, it causes all kinds of mental confusion.
Well, the good news is that his CAD program takes care of flipping that when you move the part to the bottom.
Okay,
but
good.
not all CAD programs do that. I guess the higher end ones do. But
Yeah.
we did manage to get a header connector on the back once that was pinned out for the top.
Yeah.
It was not good.
Yeah, don't ask me how I know.
Yeah.
Really.
Been there too many times. Don't want to have to solder powder.
Yeah, we did a ribbon header once, and we managed to flip power and ground on the backside.
Oh.
So when you plugged it in, the ribbon cable caught fire.
Oh, neat.
That's a feature.
Yeah, it's a self-illuminating problem finder.
Hey, just testing your ribbon cable manufacturer.
There you go. Well,
Anyway,
guys, I'm gonna have to split here. I'm gonna say 7 threes.
Okay.
Take care.
7-3.
I think I'm going to say 7-3 as well.
Yep. 73 from here.
7-3, Nathaniel. Are we pretty much done, Tom? Does it look okay?
Yeah, I think it looks okay. And you and I have